This video is on section 11.8, expected value. Expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. It's like computing an average over the long run. The standard way to find expected value is to multiply each possible outcome by its probability and then add these products together. So let's look at an example here. We can use expected value to find the outcomes of the roll of a fair die. And we know that the outcomes are 1, 2, 3, 4, 5, 6. And each probability has a 1 in 6 chance of happening. So we're going to multiply each outcome by its probability and then add these together. Expected value is this letter E, and it is not the same E that we had back in section 11.4. So here's a little chart. Here's the outcome that can happen on each of the faces of the dice. And then the probabilities. Product means multiply, so I'm going to multiply right across the row. I'm not going to reduce the fraction because at the end I have to add. So 1 times a sixth is 1 sixth. 2 times a 6 is 2 sixths. 3 times a 6 is 3 sixths. 4 times a 6 is 4 sixths. 5 6, 6 6. And if I add all of this up, this will be a fraction with a denominator of 6 because it's a common denominator. And I get 21 over 6. Now what that means as a decimal is 3.5. What this means is the expected value of the roll of a fair die is 3.5. This means that if the die is rolled repeatedly, there is an average of 3.5 dots per roll over the long run. Obviously, you can't get 3.5 on the face of a die, but we're talking about the average of the numbers you would record. So take a look at this. I used a random number generator to generate numbers between 1 and 6, which would be like rolling a die 100 times. And if I add all of this up, I get 355 for my sum. Divide by 100, because we're talking about the average over time, gives me 3.55, which is pretty close to that 3.5 we got by doing the expected value. So you're not going to be doing this. I did this just to explain to you what the 3.5 was referring to. If I had perhaps done this 1,000 times, I'm going to get closer to the expected value of 3.5. We're going to play a game which is a spinner game. The cost is $1, which you will not get back even if you win. This is what you will win. We're also going to assume for purposes of the game that the spinner just cannot land on a line. If it lands on a line, we spin again. Here's my outcomes. I could earn $0, I could earn $1, I could earn $2, or I could win $10. So you get the probability. I've got to look at this fraction-wise. This looks to me like it's a fourth, and this piece over here is a fourth, because think about just those lines. I've chopped it into 4 pieces. Well, a fourth plus a fourth is a half. So you have a 1 out of 2 probability of landing on 0. $2 also is a fourth. Now these occupy together 1/4, but I have taken that 1/4 of the circle and chopped it in half, which really means each of these will be 1/8 of the circle. So the probability that the spinner will land on 1 is 1 out of 8, and the probability that the spinner will land on 10 is 1 out of 8. Now the products, let's multiply straight across. So 0 times a half is 0. 1 times 1/8 is 1/8. 2 times a fourth, I'm not going to reduce because I'm going to need a common denominator in a minute. 10 times an eighth is 10/8. The common denominator is eighths, and if I multiply bottom and top by 2, I get the fraction 4 over 8. And if I add all this up, it is 15 over 8. Now, since we're talking money, let's change it from a fraction to a decimal, and this is 1.875, which I'm going to round off to $1.88. Now, remember, we paid $1, so we're not getting that dollar back. What this 88 cents refers to is that on the average, over the long run, I can expect to win 88 cents per game. Will I win 88 cents every single game? No. I might lose, I might win the big one, the $10, etc. Average all that up, and over the long run, I'm looking at an expected value of 88 cents. Insurance companies need to look at an expected value to decide what to charge for their premium. So what this chart is showing us, it's the claims and the probability of those claims. So the probability over the years that this insurance company will pay out at $0 is 0.65. So most of the time they're not paying out any kind of claim. So the product of 0 times 0.65, of course, is 0. 50,000, a claim of $50,000 happens 21% of the time, 0.21. So 50,000 times 0.21 is 10,500. They have had to pay out a claim of 100,000 9% of the time, which is the decimal 0.09. Multiply that together, gives me 9,000, etc., etc. So 0.02 times 150,000 is 3,000. 0.02 times 200,000 is 4,000. And 0.01 times 250,000 is 2,500. If I add all of that up, that is my expected value, and that adds up to $29,000. That is my expected value. Now, what does that mean to the insurance company? That means, on the average, over the long run, this insurance company is paying out $29,000 per claim. Do they pay out $29,000 for every single claim? No. 65% of the time, they're not paying anything. This is an average. So the expected value is $29,000. How that helps the company is this. How much should the company charge as an average premium so that it breaks even? Well, if the cost is $29,000 per claim, then it just needs to charge $29,000 if it wants to break even. Well, what company wants to break even? What do they want to charge if they want to make a profit of $50 per policy? Just add $50 to that, and this is what the insurance company would be charging so that they can make a profit of $50 per policy on the average. An architect is considering bidding for the design of a new museum. The cost of drawing plans and submitting a model is $17,000. So the cost, right off the bat, is $17,000 for this guy. The probability of getting the bid, probability that he gets the bid, is 0.4. And the anticipated profits, if he gets this bid, are $42,500. So to get the expected value, I'm going to multiply the 0.4 times the 42,500, which happens to be 17,000. And you're thinking, hey, great, he's going to make 17,000, but he's already put 17,000 into getting this bid. So if you subtract the 17,000 away, the cost, he makes $0 on submitting this bid, even if he gets the bid. So what we pick here is, in the long run, the architect would expect to break even. A store specializing in mountain bikes is to open in one of two malls. If the first mall is selected, the store anticipates a yearly profit of a little bit over $1 million, if successful, and a yearly loss of $350,000 otherwise. The probability of success is a half. So what we're looking at is the probability that the mall succeeds is 1/2. And the profits that go with that success is $1,050,000. Now, we also need to look at the possibility of failing. Well, if the probability of success is a half, the probability of fail is a half. And because we're failing, the loss here is $350,000. I'm putting a negative on that because he is losing this money. So to figure the expected value, I need to do the probability of success times the profit that goes with that success plus the probability of failure times the loss, that's why it's negative, it's a loss, of that goes along with that failure. And that arithmetic comes out to be $350,000. On the average, this guy, if he chooses Mall 1, he can expect to earn $350,000 for the year. The second mall has a probability of success of 3/4. And the profits that go with that are $700,000. If the probability of success is 3/4, the probability of failure must be 1/4, and the loss that goes with that is negative 210,000. So doing the same arithmetic I did up here, we're going to do the probability. I've changed it to a decimal to make it easier to use on the calculator. So 0.75 times 700,000 plus 0.25 times negative 210,000. Remember, it's negative because it's a loss, because it has failed. And this will give me 472,500 is the expected value for that mall. So, which mall should be chosen in order to maximize the expected profit? Well, obviously this one, which is Mall 2. In a product liability case, a company can settle out of court for a loss of $350,000. So out of court settlement, right off the bat, $350,000. Or it can choose to go to trial. Losing, making this a negative, $1,005,000 if found guilty, and of course losing nothing if found not guilty. Lawyers for the company estimate that the probability of a not guilty verdict is 0.8. So the probability of not guilty, NG for not guilty, is 0.8. Not guilty, there's $0 associated with that. If he's not guilty, he's not going to lose anything. But the probability of guilty will be 0.2. And the loss associated with guilty is losing $1,500,000. So multiplying probability times the profit or loss is 0.8 times 0, which I didn't really need to write that down, plus 0.2 times negative $1,005,000 makes a loss of $300,000. Now that's going to court, found guilty, we would expect to lose $300,000. If they settled out of court without letting it go to the jury, they'd have to pay out $350,000. So what's better, to pay out $350,000 or to pay out $300,000? And obviously to pay out $300,000 is better, so his decision is go to court. So to answer this question, should the company settle out of court? No.